Hello everyone from CodeYourFuture. It's me, Luciano, and for this screencast I'm gonna be showing you how to solve the TDD Kata Password Verifier, which was part of your homework for week 7. The reason I decided to pick this kata was because although it was part of the homework as an optional kata, I haven't seen any students solving it. Most of you solved either the Fizzbuzz kata or the Roman numerals, which is fine. So I'm gonna be showing you how to solve this password verifier then. One thing that I would like to say is this is the first time ever that I record a screencast, so it's quite an experience for me as well, and I'm very happy to be doing this for CodeYourFuture, so I really appreciate the opportunity. Apart from that, it's even if it's the first time I record a screencast, it's not the first time that I do this kata, and I'm saying that because when you see someone showing or demonstrating how to solve a kata, either on YouTube or in front of the projector, it very rarely is the first time that this person solved the kata, and it's purely because we want to show you one clear path without eliminating basically our struggles, to not get yourself confused with the solution or with the flow or with the techniques that we want to show. So it's the same for me in this case. I've solved this kata before, and I'm gonna show you in a very clear way, trying to break down my thought process so you can understand it. Another cool thing about the screencast is that you can actually pause it, go back and forth, of course, it's a video, and take notes and learn as you go, instead of just going to Sunday class and see it once and then that's it. Alright, before starting the kata, I would also like to talk about the tools that I'm gonna use, and the code editor that you're seeing now you are already familiar with. It's the VS Code that you've been using on your Sunday classes. I may have removed a few windows or a few toolbars, but just because I feel more comfortable having it cleaner. Another tool that I'm going to be using is the terminal for doing all my Git procedures, like committing the code, pushing to my own branch, and also to be running tests. You can see that there is some embellishment here on my terminal. Don't worry about this. This is just some custom things that some of us like to put. In this case, for me, it's just to get myself familiar with where I am at the moment. And in this case, I'm in the JS exercises TDD directory. If I type pwd, you can see that's exactly where I am. Okay. And since I'm talking about tools, I would like to point out how you should get yourself familiar with the tools that you're using. I know this is something that will come with practice and as you go along with your journey, but it's very important to know your tools and to know where they are as well. Just as an analogy, try to imagine a mechanic or an artisan doing her work, and imagine that during the hours of her work she needs to get up every time to find out where she left a brush or where she left that Allen key. It's very uncomfortable and it breaks her flow. It completely breaks her workflow. When you're working, when you're like in the zone, you don't want your thought process to be interrupted, and that is the same for us developers. We want to know where our tools are, and that is why, for example, I have my VS Code in front of me, and to get to my terminal I just press one combination of keys. I'm not gonna tell which combination it is because it's very personal. Each one has its own shortcuts, but I know exactly how to switch between them, and that's important because then I do not break my flow. Again, this is something that requires practice. It's going to be part of your journey, but it's good to know from the beginning. Okay, so let's get started with the kata then. I'm going to read the instructions and then we can proceed. So this is the Password Verifier Kata, and the very first line here, it says that we should create a password verification class called Password Verifier. And if we go down here to the first feature of this kata, it basically tells us to add a verify method that contains the following verifications. The first one is to make sure that the password should be larger than 8 characters. The second one is that the password should not be null. The third one should be that the password should contain at least one uppercase letter. Then the fourth one is that the password should have one lowercase letter at least. And the last requirement is that the password should contain at least one number. Then if we carry on here on line 14, it says that we should throw an exception for each of these cases that fail, and the message should be of our choosing. There are other features that we should implement here as we go. Let's not worry about them now, because what I would like to show is how we approach each feature in isolation. Just trying to imagine as you're working in as if you would work in a project, and then the product owner or the client comes to you with one set of requirements, and then you implement them, and then sometime later the product owner comes to you with another set of requirements, and this new set of requirements may or may not break the current feature that you implemented. So you will have to perform some changes, and that's one of the goals of this kata. Also, as this kata suggests, it's a TDD kata, and we will be test driving all the way to the solution. And the technique that I'm gonna show you is some people call it baby steps, which basically means that we're gonna be taking very small steps to solve the kata, and for every small step we're gonna be committing and pushing the code to our branch. Alright, so let's start by creating a new branch on our project. I'm gonna type git status, so you can see that I'm still on branch master. I'm gonna go ahead and create a new branch, and again, don't worry, I have some shortcuts from my git. I can come back here and type the whole thing. So git checkout branch, and I'm gonna type password verifier. That should be it. Okay, so now I'm on a new branch. I'm gonna clear this up, and let's just for the sake of doing it, let's try to run test and pass password verifier, because that is the name of the director of the kata. And let's just see what happens if we do that before doing anything else. So as we can see here with npm, it basically tells us that there are no tests found. And by the way, we are using the jest library for tests. It was already provided for your project, for your homework project. So it basically says that we don't have any tests yet written. So let's go there and write our first test. So I'm gonna open the File Explorer here, and I'm gonna click here on File, and I'm gonna type password verifier .test.js. Remember that our test should have the extension test. So let me hide that window now. Cool. And as I said, we're gonna be doing TDD, test-driven development. So in test-driven development, you should start from the tests, and that's what I'm gonna be doing here. So I'm gonna be writing test, and if we go back to the requirements, it says that the password should be larger than 8 characters, and the password should not be null. Now we could start from the first one, password should be larger than 8 characters, but if we have a password that is even one character, we already know that the password is not going to be null. So to me it makes sense that we should actually start from the second verification that the password should not be null, because if the password is null, then none of the other verifications gonna pass anyway. So to me this is like the most important verification that we can do right now, and also the easiest one. Okay, so let's go back to our test and write exactly that. So test password should not be null, and we're gonna open here a new function to write our test, and we can start it fairly easy. What's going on there? Verify password verifier, and observe that I'm typing here variables that I haven't created yet, and that is exactly what I want to do actually, because say we're test driving our code, so we are writing the test even before we write the implementation itself. So let's go to password.verify, and let's pass the null value. And what I want to test here is that, as we can go back here to the readme file, to the instructions, each one of these verifications should throw an exception with a different message of our choosing. So basically what I'm gonna do here is call the verify method with a null value, and I want to observe that this is gonna throw an error with a message that I'm gonna decide which one it is. Okay, so these are helper methods from the Jest framework, the Jest library, and well, I've done this kata before, so I know that they exist. But with whatever library that you're working, it's very important to actually check the documentation and get yourself familiar with. So let's go back to the readme once again, just to see the message that we have available. I'm just gonna use this password should not be null as the error message itself, because it's part of the requirements. So to me it makes sense to use it. So let's go here and just paste it. So password should not be null. Okay. This is very simple, very small, and a very small test that makes sense to me. So I'm gonna save it, and we know that this password verifier variable has not been initiated yet. We don't even have a password verifier class. We don't have anything yet. Still, I want to go and run the test so you can see exactly what's gonna happen. So again, npm test dash password verifier. Okay, so the message is different from the previous one because now it at least found a test, right? Password should not be null. That's the name of the test that we just described. And then we have verify is not defined. So we're gonna come back here and try to figure out why verify has not been defined. And of course, the verify method is incorrect. It is actually expect, and this expect method actually takes a function inside. So we made a few mistakes there, which is fine. This is Jest library's way to handle it. So instead of calling the method itself that we want to verify, we are passing a function to it. So this is how we're doing here. we're passing a function, and the expect method is gonna call this function later, and this is how it manages to handle this expectation here to throw the error. Okay, so let's save this again, and let's run the test and see what happens. So I'm gonna clean this. I'm gonna type npm test dash password verifier, and good. Now the error message that we have is the test expected the function to throw the following error: password should not be null. But instead, what we got is password verifier is not defined. So what is happening is that the variable that we have here, password verifier, has not been defined yet, which is exactly what we expected to happen. Okay, so let's define this variable right now. Password verifier equals new password verifier. So this is the class that we just defined. We don't have the class defined yet, so let's do it right here on top. Password verifier, and let's open this and close, and let's save it and run the test again and see what happens. Let me clean this and run the test. Okay. Now the error is a bit different. It's saying that password verifier.verify is not a function. So let's go back to our test and define the function verify. I know this is very slow, but I just want to show this in the beginning, and later on we can carry on a bit faster. But what I'm trying to show here is how we can actually read the test and use the error message from the test to help us drive our implementation. Okay, the tasks are there to help us and not to work against us. So let's use that, right? So let's define the verify function here. That takes a password. We open close this, and let's run the test again and see what happens. Again, I'm gonna clear my terminal and run the test. Awesome. Now it says that again we expected the function to throw an error, but it did not throw anything, which is fair enough. We are not throwing our error yet. So let's go to back to our implementation and throw the error. So I'm gonna go back here, and I'm gonna throw the error. And I know this looks a bit silly because we just say that when we pass the password has a new value, then it should throw the error. But if we go back to line 3 here, we're not doing any verification of the password whatsoever. We are just carry on and throwing the error straight away. It's fine. This is the very minimal implementation that we need in order to make this test pass, and that's how we should approach our code during test-driven development. It's not necessarily the way that you would do it in your day-to-day work. That's not exactly how I approach it when I'm working, but this is not the moment to. That's not the moment that I am at work. This is a moment for me to learn. So while doing that, I can actually do it step by step, small steps, and observe what happens. Okay. So now I'm gonna save. I'm gonna go back to my code, to my test, and let's see what happens now. Let's run the test again and see what happens. Our test finally passes, and that's great. So what do we do when we have a passing test? We commit the code. And the reason that I want to commit it right now is because if anything goes wrong with our code, if we get a bit lost, we can always revert the changes, and we will continue to have this commit with a passing test. And that's how we want to approach our code. We always want to have it very small commits with our test passing, so we always on control of it. Okay, so remember, we always want to keep in control of the code that we write. So I'm gonna write here password should not be null. Okay, so now I'm gonna push this code, and Git's just telling me that he doesn't know where to push, so I'm gonna just make it explicit. Git push origin password verifier. Good. Now it created the remote branch password verifier, so we can carry on. So I'm gonna clear my terminal again, and let me go back to the code editor. Alright, so now that we have one code passing, you might think that we should just carry on and maybe do some more work to test actually and to verify that the passwords know. But what I would like to do is actually check the next step before going on with our implementation. And the next step, we can pick any of these verifications. I'm gonna pick the first one. It seems quite straightforward, which is just detect the length of the password, and the password is just a string. We already learned how to check the length of a string. So that said, let's go back to our test and write that up. So I'm gonna create a new test here, which is password should be larger than 8 characters. I'm gonna open the function, start new function, and similar to our first test, I'm gonna write expect. I'm gonna pass a function to this expect. Gonna do the password verifier dot verify, and to this I'm gonna pass. Now we already know that the password cannot be null. What is the maybe the minimum condition to throw the error that we want? If the password needs to be larger than 8 characters, I'm gonna type just about 8 characters and verify that this is actually throwing an error. And the error message, just like in the first test, we follow the kata description. We can actually do the same here, because this is very descriptive. Password should be larger than 8 characters. So I'm gonna go back to my test, and I'm gonna paste this here, and characters. I'm gonna write it fully. Alright, we know that the password verifier variable has not been defined here, although it has been defined in the first test. I'm gonna run the test so you can actually see this breaking. So let's go back to npm test password verifier. Alright, password verifier is not defined, so again it's the same error that we've seen before. So let's go back to the test and define that password verifier variable. Now we could come here and just do the same as we did with the first test, but we already know what's the name of this, and this is code duplication. Some people would be okay with this, some people would not. What I would like to show you, just like how we can extract this is actually quite simple to do, and we know that we're gonna be writing more tests for this kata, which means that for every test we're gonna have to be creating this constant over and over again. So instead, why don't we just take it from here and define it here? So by defining the password verifier here on the top, then we can use it across all of our tests, and that should make it easier for us. Alright, so let me save this now, and let's run the test again. Good. Now what we see here on the top is that the first test is still passing, right? We did not break our first test. The second test, on the other hand, is breaking, as we expected it to do. And if we check the error message, it's actually saying the password should be larger than 8 characters. which is what we expected, but instead it threw password should not be null. Okay, and if we go back to our code, it seems quite obvious why. The verify method, all it's doing is throwing the error password should not be null. Okay, so what can we do in order for our code or implementation throw the password should be larger than 8 characters? Now, observe that the second test that we wrote is actually forcing us to implement the behavior of our code. And again, that's another goal of the test-driven development. That's how it should be. You should always aim for the minimum amount of code to pass the tests, okay? Even if sometimes this seems a bit silly, if you carry on writing the test, it should actually drive you towards the implementation, okay? And if it happens so that it's not driving you towards the correct implementation, then maybe we should think again about the test that we're writing. In this case, we are going towards the right direction. So what we're gonna do now is if password is equal to null, then we're gonna carry on and throw the password should not be null. Okay? Otherwise, I'm gonna throw error, and the message is gonna be this password should be larger than 8 characters. Okay, so I'm gonna come here, I'm gonna paste password should be larger than 8 characters. So let's save this and let's run the test again and see what happens. Brilliant, now we got 2 tests passing. Okay, so let's commit the code again as we did before. Password should be larger than 8 characters. Let's push, and since it's telling me the same message as before, what I'm gonna do is instead just follow the git instructions -- set upstream origin password verifier. So by doing this, the next time I need to do a git push, I will not need to type over again origin password verifier. Okay, now let's go back to our test, and before proceeding to the next verification, I just want to see if there's any improvements that we can do in this code. As I said before, the class password verifier started in the same file that the tests are. Of course, this is not the end code that we want. We want our production code to be separate from the tests. And now that we reached a point of enough complexity with some implementation on it, we can actually move this to its separate file. So what I'm gonna do is go back to our Explorer and create a password verifier file. So let me close this now. I'm gonna go to my test, and I'm gonna get rid of the class from this file here, and I'm gonna put it in my password verifier file. Okay, and as we've already learned with JavaScript, we have to use the module exports to actually export the class that we want to use. And we go back to the test, and now that we don't have it here anymore, now that we don't have the password verifier class here, we have to import it. So let me do this: password verifier equals require, and let's output the path. Okay, so I'm gonna run the test again now that we performed our very first refactoring, and I want to make sure that our test works. Or sorry, I want to make sure that our test pass. Remember, always small steps to always keep us under control of our code. So I'm gonna go and I'm gonna run the test. Good, so we did the refactoring, our test is still passed, which means that we did not break our code. So I'm gonna go and commit again. I'm gonna do extract Password Verifier class. Okay, that's good enough. I'm gonna push the code. Good. Now, every time that we want to run a task, we've been doing npm test -- password verifier. This may be okay, but I find it a bit time consuming. There is an alternative to that, which is to keep the test running, and it's gonna be, let's say, watching for changes in our file. So every time we save the file, the test suite is gonna rerun the test automatically for us. So that makes it much easier for us to proceed, and saves us from having to type over and over again npm test. I'm gonna show you right now how it works. So we're gonna continue with this npm test password verifier, but after that we're gonna type watch. Okay, so if we observe now, our screen is a bit different. It gives us some information about the usage. It's fine, we don't need to worry about this now. How we need to worry about is that our test now is constantly watching us for changes in the code. So if I go back to my code just to show you how this works, I'm going to introduce here a breaking change. So I'm going to go to my first test, just going to put some foo here. So this should break the code because the error message is different from the error message that we're expecting is different from the error message that's actually being thrown. Okay, so if I save my file now, my test, and I go back to the terminal, we can see that the test has actually already been run for us. So you see, we did not need to run the test again, and this makes things much easier for us to proceed. So I'm gonna go back, fix the test back, save it, and we can see that everything is good again, right? How cool is this? So with this we have like a much faster feedback loop. Okay, talking about feedback loop, that's another good point for me to stop for a few seconds. Remember when we discussed systems in our week 7, we discussed that a system is composed of inputs and output, and each component of a system interacts with each other. We can imagine ourselves exactly the same way. We, along with our coding environment, we also form a system. And as I type on my code editor and I save my files, my task suite is gonna run, and the result that is gonna print is gonna feed back to me, and I can read it, and I can go back to my code editor and proceed with the code. So you see how this cycle happens. I type something, I save, oops, I save, I watch it break, I read the message, I go back again, I fix, and I see it. You see how the system works, and that's how we're gonna carry on from now on. Alright, let's go back to our README and let's check for the next feature to implement. Okay, let's go to validation number 3, which is password should have one uppercase letter at least. Let's go back to our test, and just to speed this up a bit, I'm gonna actually start copy and paste this. You know, they say the developers don't copy and paste. Don't really believe that. That happens way more often than you think it does. So password should have one uppercase letter. Should have at least one uppercase letter. Okay, and how we can proceed with our task knowing that it already cannot be null. It must be larger than 8 characters, and now we have yet another validation, which is that it must contain at least one uppercase characters. So this is already not null, right? And if I just introduce another character here, then we have 9 characters, which should pass the first 2 validations. Okay, but it should not pass the third one because we do not have any other uppercase letter. So again, observe that for each test that I am writing, I am forcing my code to evolve. Okay, so let's go back to the README and just get that message. Password should have one uppercase letter at least. Again, I'm gonna use this for my error message. Oops, did I get the wrong one? Let me try to copy this again. Okay, so password should have one uppercase letter at least. Alright, so again, I'm gonna save this test, and let's observe that the test, the Jest is gonna run the test for us without us needing to actually type it. See, now we got our third test here, which is breaking, and we have the message, password should have one uppercase letter at least. Good, let's go back. Let's carry on to our Password Verifier class. And what can we do to make this test pass? Just like we did for the very first one, for the very first test, what we're gonna do here is check the length of our test. And if this is smaller than 9 characters, then this should throw an error. Password should be larger than 8 characters. Otherwise, this should just throw the uppercase error that we just introduced. Okay, so password should have one uppercase letter at least. Now, if I save this file and check the test result, you see it passes now. Alright, so again, let's go back and do a git status. Good, let's commit this file. Let's add everything. Let's commit. Password should contain at least one uppercase character. Okay, now let's go back to our file and let's check the next feature. And the next feature is, or the next validation, password should have one lower letter at least. Very similar to the previous one. Let's go back to the first test. Or let's go back to our tests. Okay, very similar. I'm gonna copy this just to speed this up a bit. Should have at least one lowercase letter. Okay, so this is interesting. If before it should contain at least one uppercase letter, and now we need to force it to pass all the previous validations but contain at least one lowercase letter, how can we do it? Well, what I can do is just, if I can at least get back into control of my cursor. Okay, so what I can do is just go here and make everything uppercase. Okay, so what happens if I make everything uppercase is just that it should throw an exception showing that saying that I should have at least one lowercase character. Alright, so let's go back to the README, copy that error message, and go back to our test, and put it here. So password should have one lowercase letter at least. Alright, let me save this, and let's watch our test. And okay, it says that our password should have one lowercase, but actually what we got is the password should have one uppercase letter. So let's go back to our implementation and let's fix that up. So we have to introduce the verification for the password having at least one uppercase letter. And what we can do is check if to lowercase is equals to password. So what I'm saying here basically is if I transform my password to lowercase, and if it still equals to the original password, it means that the password does not contain any uppercase characters. So these exceptions should be thrown. Otherwise, we're gonna throw the lowercase exception. Okay, let's go back to our tests. Brilliant, it passes. So we go back to Git, and I'm gonna add everything, and I'm gonna commit. Password should contain one lowercase character. Okay, now let's go back to our test and see what is the next feature that we should implement. So last validation, password should have one number at least. Alright, let me go to our test. Again, speed this up. Password should contain at least one number. Alright, so with all the validations that we had before, what I'm gonna do is have one uppercase here, so it should pass the uppercase validation. Then we have all the lower cases, so it should pass the lowercase validations. We have 9 characters, so it passed the 9 characters validations, but we do not have any numbers, so it should fail the numbered validation. Okay, so I'm gonna come here, I'm gonna copy this error message, and I'm gonna return here, and I'm gonna paste it here. Okay, I'm gonna save, and I'm gonna observe my test breaking. Good. So password should contain one letter is what we receive, but we were actually expecting that the password should have one number at least. Let's go back and let's see how we can implement this. Okay, so again, let's make password dot to uppercase. So this is, I'm trying to pass the test. Observe that I'm trying actually to implement the to uppercase character, right? So that I'm doing the very minimal, always the very minimal step to make my test passes. Alright? I'm not even implementing the number validation yet. So password should, and what is the error message again? Password should have one number at least. Let me go back here. Password should have one number at least. Okay, so let me save this. Let me go back to my test. Everything passes. Okay, so let's go back and let's commit this code. Password should have at least one number. Good. Now let's go back to the README file. It seems that we have implemented all the validations, right? That we have. So what I want to do now is write a test that ensures that all the validations passes fine and that we have a good valid password. And this is the test that's gonna make sure that everything is working fine for us, because so far we have been implementing the very, very minimum for making our test pass. We were just listening to our tests and making it pass. Right? Now we want to test actually for what we call the green scenario, which basically means that when everything works fine, when all the validation should pass, what do we expect to happen? And in this case is we expect our password to be verified just fine without any exception. So what I'm gonna do here is copy this test and say password should be valid if passes all validations. Okay, and what is the minimum password that we can have that's actually gonna pass all the validations? Well, we already know that this contains an uppercase character, this contains lowercase characters, it contains more than 8 characters, so let's just add a number here, the number 1, and this should be enough to not throw an exception. And this is how we're gonna do it using this jest library for testing. Okay, so we expect it to not throw any kind of error by not passing the message. We just say like it's not gonna throw any kind of error. So let me save this now and let's check our password, and indeed we are seeing the exception being thrown. Password should have one number at least. So now we're gonna go back to our implementation and we're gonna fix this last part of our code. So the way that I'm gonna do this is we have to check for each character of our password whether it's a number or not. Okay, so what I'm gonna do here is basically splitting my password. Remember, the password is a string, and by doing this, calling this split with an empty string, I'm gonna breaking it down and transform it to an array where each element is gonna be one character of that string. Okay, and then I'm gonna use this function which comes with arrays in JavaScript, which is called every. And what this function does is basically you pass a predicate, which means that you pass a function that returns a boolean or verification to this function, and if all the elements on this array satisfy this function that I'm gonna pass, then this whole thing is gonna return true, right? So this every method is gonna return true. So I'm gonna show you here. So I'm gonna read it for every character. If this again is another helper function from JavaScript. Oops. So from every character, if that character is not a number, then this whole function, this whole if statement is gonna be false. Alright, so reading again, password.split, so this now is an array, and for every element of this array, which is a character, if for every character is not a number, this is NaN stands for is not a number, and I do apologize, there is no need for this here, this negation. So if every character is not a number, then I'm gonna throw the error saying that we should contain at least one number in our password. Alright, and otherwise then no error is thrown. The verify function is not gonna do anything, and this should assert that our password is actually valid. Okay, so let me go back, save this, let's check our test again, and brilliant, our test passed. So if we go back quickly to our tests, we have so far checked for every validations, and we assert that they actually throw errors when those validations fails, and now we also have checked for when all the validation passes and no error is thrown. So let me go back here, and again I'm gonna commit and say password is valid if passes all validations. Alright, let me push this. Good. Let's go back to our code, and although our tests look very small and nice, we have this function here, verify, which is kinda big, and what I'm gonna show you is just one way to refactor this code. Some people will like it, some people will not like it. I'm gonna show it to you just for the sake of showing a bit of refactoring as well, right? What I can do here is start extracting each validation to its own function. Let's see how it looks like. So I can do something like const not no. So this is going to be a function that takes a password, and I'm gonna copy this, I'm gonna put it here. Okay, so not no is a function that takes a password and just checks. So if this is not no, then it well, if this is no, then it throws error. Okay, so what I'm gonna do it here now is call this function not no password. So this is a validation method, and what I'm saying here basically is that I'm verifying that the password is not no. I'm gonna save this, and I'm gonna run the test and make sure that my refactoring did not break my code. Let's go back to our test. Everything passes. Cool. So it means that this refactoring works. I can carry on and do more of this. So let me copy this now. 27 constant. I can put it larger than 8 characters. And again, this is a function that takes a password. and I'm gonna paste this. Okay, so if password is if the length is, oops, I forgot the error here. So if the length is less than 9, I'm gonna throw the error, and here on top I can just carry on and type larger than 8 characters, and I'm gonna pass my password. I'm gonna save it. I check my task passes, so I can proceed. Okay, I'm gonna do the same here for the rest of the functions, and it's gonna be at least one uppercase character. Gonna paste this. So if the password doesn't contain any uppercase characters, this should fail. At least one uppercase character, password. And again, I'm gonna speed this up a bit. So I'm gonna copy this. At least one lowercase character. I'm gonna copy this, put it down here, format, at least one lowercase character, password, good, and the last one, at least one number. Get this, paste it here, format, at least one number, password, and get rid of this, let me get rid of these empty lines. So very concise, so verified not null, larger than 8 characters, at least one uppercase character, at least one lowercase character, and at least one number. Let's save all of this, check our task. Beautiful, everything still passes. Now let's go and commit this code and say refactor, or we can even say extract validation functions. Okay, let's push this code. Awesome. Let me go back, and we are finally done with the first feature of this kata. Alright, the remaining of the kata is about changing the existing code, is about refactoring towards new requirements, and that is a different subject from what we've been covering so far. Okay, what we've done so far is to add new code and test driving the implementation of brand new features without breaking the existing code. And the second part is actually covering another subject, which is, let's say, refactoring. And in order to refactor the code, we would need to change both the test that we have and the implementation. And that is a different subject. The technique is somewhat different. So what I want to do is stop the screencast for now, and I will let you watch this and let me know if you would like me to proceed with the next features and show you how it's supposed to be done, and I'll be very happy to carry on. So I really appreciate your time watching this video, and I hope you enjoy it. Let me know if you would like me to continue, and I'll see you on Code Your Future on a Sunday class. Bye bye.